Hi guys, hope you're all doing well and coping with the lockdown. It's pretty exciting times for us all, but yeah, I hope you're making the most of it. This is my first time doing a video lesson, so probably going to make lots of mistakes. I guess you guys are already used to that. I put up some pictures around the edge there, so feel like we're at school. Yeah, so let's get right into it. So I've updated our level 2 chemistry Google Classroom. If you click on classwork here, you're going to see my video lessons are going to be put into this folder here, COVID-19 video lessons, and we're going to be working on bonding structure, properties, and energy. The first part we are looking at today is ionic substances, and obviously you have access to these slides as well, so please look over them for some revision. Let me open that up. We are going to be using this book, the SciPad External. It's the bigger one. If you haven't got that yet, contact me, send me an email as soon as possible, and I'll see if I can help you out. We really do need it. Actually, let me just go back to the SciPad. There we are. So what I want you to do first is from page 9 to 9 to 21 is all revision from last year. You should know how to do this. You probably have forgotten how to do it, so I would like you to go over all of this first before you start on the next subject. It's basically how to make ionic compounds, balancing ions, looking at chemical reactions. All of the information is at the top. Read that, do the questions. Any questions? Ask me, of course. But what we are looking at today is the first introduction to ionic substances. So what is an ionic substance? First, we'll look at this periodic table, and we can see that it's split into two parts. The yellow bit on the right, which are nonmetals, such as oxygen, nitrogen, carbon, and the bit on the left, which are metals. We've got sodium, copper, iron, tungsten, stuff like that. One moment. Now, if we have a bond between a yellow and green, or a non-metal and a metal, that is going to be an ionic bond, making an ionic substance. If it's two or more non-metals bonded together, that will be a molecular substance, and we'll be looking at that later. And if it's just metals bonded together, that will be a metallic substance, obviously. So, ionic substances are made up of ions. Ions are formed when an atom loses or gains one or more electrons. Metals, the guys on the left, such as calcium and iron, will always lose electrons. And because they've lost electrons, they become positively charged. That is because they now have more positively charged protons and negatively charged electrons. In this case, calcium has lost 2 electrons, so it now has a charge of +2. Non-metals are the opposite. They will gain electrons and become negatively charged, such as oxygen here. Oxygen has gained 2 electrons, so oxygen has 2 more electrons than protons, so it has a charge of 2-. On the top, we can see that atom, that ion, has 5 protons and 3 electrons. It's got more protons than electrons, so it's positively charged, and we can call that a cation. Cation is just a positively charged ion. If you want to know how to remember cation means positive, You can see the T in cation kind of looks like a plus sign for positive. The opposite is an anion, and that's when an atom gains electrons to become negatively charged. An ionic substance consists of anions, positively charged, and cations, negatively charged. Sorry, other way around. An ionic substance consists of anions, which are negatively charged, and cations, which are positively charged. The ions are arranged in a three-dimensional lattice. That picture below here is a 3D lattice that is regular shaped, and they are alternating positive and negatively charged ions. This substance here is made of sodium ions and chloride ions. It is called sodium chloride, and it is table salt. I'm sure you're all very familiar with that. Table salt is the quintessential ionic substance. So when you think of any properties, when you think of an ionic substance, just think of table salt. I'm sure you're familiar with it. An ionic reaction. So ionic substances can be formed by the reaction of a metal with a non-metal. In this case, we've got sodium metal and chlorine gas. The metal gives one or more electrons to the non-metal. So in this case, the sodium gives its outermost electron to chlorine, giving chlorine a full outer shell, and that means sodium will now also have a full outer shell and stable. This diagram is just showing the outer shell, so we can't actually see the inner shells of sodium or chloride here. I'm just going to show this quick video about ionic bonding. We would have gone over it last year, but this is just a little recap.
We have previously learned about the formation of ions. Now we will learn about ionic bonds. Ions, as you already know, are formed from the loss or gain of electrons. Electrons, however, do not suddenly appear or disappear. They are, in fact, transferred from one atom to another. Let's look at sodium chloride as an example. Sodium loses one electron to form a sodium ion. The electron is not lost, but transferred to chlorine to form a chloride ion. So we have a sodium ion and a chloride ion. They are oppositely charged ions and will be electrostatically attracted to one another, much like how opposite poles of a magnet are attracted to one another. This electrostatic attraction is an ionic bond. Sodium chloride is an ionic compound because it is held intact by ionic bonds. The same thing happens with magnesium and oxygen. Why don't we grab a piece of paper and a pencil and draw the resulting ionic compound, magnesium oxide? Please pause the lesson and resume when you are done. Magnesium transfers its two valence electrons to oxygen, forming a magnesium ion and an oxide ion. The resulting ions are electrostatically attracted to one another, forming an ionic bond. Did you get this right? Did you remember to include the charges on the ion? Now, let's look at calcium and chlorine. Calcium loses two electrons to form a calcium ion. One of these electrons is transferred to a chlorine atom, and another is transferred to another chlorine atom, forming two chloride ions. The calcium ion is electrostatically attracted to the two chloride ions because the opposite charges must fully balance each other out. In all three examples, the resulting ionic compounds have an overall neutral charge because all charges are fully balanced out. In summary, an ionic bond is defined as the electrostatic attraction between oppositely charged ions. When an ionic compound is formed, The charges must be balanced so that the resulting ionic compound has an overall neutral charge.
Alright, so that's a recap over some ionic reactions and how ionic substances formed. So the way these ion particles are held together in the ionic substance is through this ionic bond. So cations and anions have opposite charges, positive, negative, and that means they attract each other, similar to the different ends of a magnet. If you try to put two different ends together, they will attract each other. If you put two of the same end together, they will repel each other. This works just the same in cations and anions. There is a strong force that holds the ionic substances together, and we can call this the electrostatic force. That is any force between a positive and a negative substance. So this topic is called bonding structure properties. So we looked at the bonding, ionic bonds. The structure is this lattice shape. And now we're going to be looking at some of the properties of ionic substances. So the first one is the melting point of ionic substances. If you think of salt, if you heat up salt, does it melt? Not usually. You need to heat it up lots and lots. So melting is the state change from a solid to a liquid, such as ice melting. Melting requires breaking the forces holding the particles in the substance together. If the forces holding the particles together are very strong, a lot of energy or heat is needed to break these bonds, and the substance will have a high melting point. If these forces are weaker, however, we won't need as much energy, so the substance will have a lower melting point. The electrostatic forces, or the ionic bonds in the ionic substance, are strong, because one's very positive and one's very negative. There are very strong forces holding it together. So ionic substances have a high melting point. You're not going to be able to melt salt in a pot or a pan. That won't work. If you want to go onto YouTube and search for a guy melting salt in a furnace and then pouring it in water, that's quite interesting, and I'll show how much energy salt can hold when it's melted. I don't have the video here, so find it yourself. But yeah, the main point is ionic substances generally have high melting points because the forces holding the ion particles together are very strong and require a lot of energy to break. Solubility of ionic substances. Solubility means how well it dissolves in a liquid. When an ionic solid dissolves, the ionic bonds between the ions must be broken, kind of like melting. Polar substances, such as water, are good at dissolving ionic solids. We are going to be looking at what makes a substance polar or non-polar soon. But at the moment, all you need to know is that water is definitely polar. Water has a positive and a negative end. The oxygen is negative. See that little minus sign there. And the hydrogen is positive. Negative bit here, positive bit there. These poles of the water are attracted to the positive and negative ions. So this chlorine ion here is negative, it has gained an electron. So it's going to be attracted to the positive ends of the water molecule. So here you can see all the positive bits are right up against the chlorine. Here we have a sodium ion on the right. It is positive because it's lost an electron. So it is attracted to the negative part of the water molecule, which is the oxygen atom. Negative chlorine ions is attracted to positive end of H2O molecules. Positive sodium ion is attracted to the negative end of H2O molecule. Good. So when we throw salt in water, the water is going to surround each ion is going to get surrounded by water. An ionic solid will only dissolve if the forces of attraction between the ions, so between the sodium and the chlorine ions. Sorry, let me start that again. An ionic solid will only dissolve if the forces of attraction between the ions and the water molecules are stronger than the forces of attraction between the ions themselves. All right, so what that means is here this water has this sodium atom here has strong attractions to the water, and because it's dissolving in water, it means its attraction to the water is stronger than its attraction to the chlorine itself. The energy required to break up this 3D lattice and dissolve an ionic solid is called the lattice energy. In nonpolar solvents, such as hexane, and once again we'll get on to what makes something polar and nonpolar, they do not have a positive and negative end. This means there are a lot weaker forces of attraction between the hexane solvent and the charged molecules. So if this was hexane, there isn't going to be much attraction between the hexane and the ions, so they're going to prefer to stay together in the ionic substance, so it will not dissolve in a non-polar substance. This means ionic solids are not soluble in non-polar solvents. If this is at school, I would show you some hexane. It looks pretty much like water. You put some salt in it, and the salt does not dissolve. All right, moving on to electrical conductivity of ionic substances. Now, what we need to know is what causes a substance to be conductive to electricity. What it needs first is charged particles. So a charged particle could be some electrons, sodium ions, anything with a charge up here like that little plus or those minuses, so ions, the sodium, the sulfate, and these particles must be free to move. There's no point having electrons if they're just stuck with one atom. They have to be able to move throughout the substance. In an ionic solid, such as solid salt, there are charged ions. We have sodium ions and chlorine ions. However, in a solid, they are locked into that 3D lattice shape and they are not able to move. So that means solid salt does not conduct electricity. If, however, we get salt and we melt it, requires a lot of energy, or we dissolve it in water, the ionic bonds are broken and these ions are now free to move around. This means they can conduct an electric charge. So dissolved salt or molten salt is conductive, solid salt is not. Now, you may think that water is conductive. Pure distilled water is not conductive at all. Water itself isn't a charged molecule, so it's not going to conduct electricity. However, as we saw before, water is really good at dissolving ionic substances. So even if you leave some water in your tank for a while, or if it's in a stream, it's going to dissolve some ionic substances. And as we've seen here, ionic substances, when dissolved, do conduct electricity. So the water you get out of your taps probably is going to conduct a little bit of electricity due to dissolved solids in it. Seawater has lots of salt in it, sodium chloride, so seawater will conduct electricity very well. Hardness of ionic substances. What is hardness? Hardness is how hard something is. So if you can push on it, will it bend? Will it leave a mark? It is different to toughness, though. Something like my coffee cup here. This is very hard. I'm not going to be able to push it and leave an indent. However, it's not very tough. If I get it and throw it on the floor, it's not going to bend, but it is going to smash into lots of pieces. Something like a rubber pipe, on the other hand, very soft. You can push it all you want, but it is very tough. If I throw it at a wall, it's not going to break. It'll just bounce off. Ionic substances is what we're interested in, and they're hard. So if you think of salt, it's very hard. It's not soft if you push it. And this is hard because the atoms are packed very closely together, and because the ionic bonds between the ions are strong. Yep. Brittleness of ionic substances. Brittle, will it break if you put a force onto it? Once again, my cup, very brittle. Something like a metal can, if you hit it with a hammer, it's not going to shatter usually, just going to bend. So metal, generally not brittle. Ionic substances are generally brittle, which means they tend to shatter rather than to form when a force is applied to them. So this little diagram here, we have our ionic substance. Let's think of it as a big salt block, and it's getting hit with a hammer. When it gets hit with the hammer, the ions are going to slide down. And as we see, when it slides down, we now have two positives, two negatives, two positives lined up next to each other. What this means is they repel each other. So here they repel each other and it will crack. So when a large force is applied to an ionic substance, the section of the ionic solid moves. Now like charges are next to each other, which causes them to repel, and the substance shatters. That's a picture of a horse. I think that's a horse. That's a salt block. I'm not sure why this picture's here. I would have put it here last year at some point. But I think it is. Imagine if you've seen one of these salt blocks before, it's a big block of salt, very hard. Definitely can't mold it at all. And if you hit it with a hammer, it's just going to shatter. All right, so that's the conclusion. This is meant to be the part with class participation, but you can say it out loud from home. So class, an ionic substance, is it hard or soft? And when we're answering these questions, just think of table salt. If you said it was soft, you were wrong. Table salt is hard, obviously. And ionic substances are hard because they're in that 3D, packed in tight to a 3D lattice shape, and very strong forces of attraction between the ions. Brittle or malleable. Malleable means you can mold it easily with force. Brittle means it will shatter. And like we just saw before, brittle. Soluble in polar solvents or insoluble in polar solvents. Just think of water. Does salt dissolve in water? Yes, it does. So ionic substances are generally, but not always, soluble in polar solvents. Conduct electricity as a solid or does not conduct electricity as a solid. They definitely they do not conduct electricity as a solid, because although they've got charged particles, the particles are locked in shape. Conduct electricity as a liquid. Yes, they do. As a liquid, the particles are now free to move because the forces holding them together have now been broken. And that's the same when you dissolve it. The water, or whatever solvent you're using, will break the forces of attraction between the ions, so now they're free to move around. All right, so that is my ionic substances lesson. If you would like to go over it again, maybe just start the video again, or if you want to do it in your own time, it is here on Google Classroom. What's going on? It's here in Google Classroom. Bonding structure properties under slides. First one, ionic substances. I've also got some revision sheets here, which you may want to look at some point, and study videos. These study videos are really cool. Click on this. And I've got a little YouTube video, YouTube playlist of videos made by a New Zealand company about NCA level 2. So we're doing this one here today, ionic substances. Open it up.
I'm going to use pretty much the most common of all ionic substances. A full means you can think of
basically what I
in
said.
The last section.
Basically what I said, but in a different form. And exam questions, I haven't put them in yet, but they will be there at some point. All right, so now for what work you have to do in this iPad. Which way? This way. So like I said, start off doing the revision work from page 9 to 21. And then after that, you are doing pages 23 to 30. Oh, that's a lot. 37. 23 to 37. We have covered everything in those in that slide. All the information is at the top of the page, remember? On page 27, let me get up on the screen here. On page 27, a moment, there it is. It's a practical. So we're not going to do this practical because we're all in self-isolation, but I'm going to tell you the answers. Describe the solvent as being either polar or non-polar. Let me tell you, water is 100% polar. Hexane is non-polar. Ethanol is going to be, we're going to call it polar, but really it's a lot less polar than water, but it's still polar. So polar, polar, non-polar, then try answer these questions underneath. There we go. Oh, you would have seen that. Also on this page here, it's another practical, which we won't be doing, but it's basically measuring how electrical current goes through distilled water, solid sodium chloride, and sodium chloride solution, or sodium chloride dissolved in water, salty water. You might be able to guess the answers yourself. Distilled water has no particles dissolved in it, so that is going to have a current of 0 amps. No current. Solid sodium chloride, it does have charged particles in it, but they're not free to move. So once again, it's going to have a current of 0 amps, while sodium chloride solution, the charged particles are dissolved and free to move. So it is going to have a current of more than 1 amps. So yeah, that's all you need to write for there. Then answer the questions below. This is a lot of work for you to do, but I've got lots of free time, and this is going to be the only video lecture for this week. I believe they've brought the holidays forward, so there might not be another lecture, another video for a while, but I'll let you know when it comes out. So that's all for me for today. If you've got any comments, please leave them below in the comment section. Like and subscribe, and hope you are enjoying. Hope you're making the most of your time off. It might be pretty boring, you can't see your friends, but try to find something practical to do while you're while you're on lockdown, go for a walk maybe. Stay away from people though, and have a good time. I'll see you later.